Algebra 2, welcome back for another amazing note video. Here we go. We're in section 5 today, guys. All right, so chapter 7, section 5, exponential and logarithmic equations. And there's some inequalities. Mainly, we are just dealing with the equation aspect of it. All right, section 4, you remember that. That was yesterday. Section 4 had a lot of properties, a lot of different ways of like converting, okay? And all of those charts that you had in section 4 are really important because you're still using those in section 5. And I know I said in the section 4 video, you will be using them basically throughout the rest of the chapter. That is the case, all right? And you're gonna immediately see that come to fruition right here in this section, okay? So we're starting with just some real basic definitions. Exponential equation, there's your definition there. You got a logarithmic equation, there's your definition there. And then you have a couple little helpful things right here. Okay, so if you were to have the same base number equaling same base number, your exponents, you could just set those equal to each other. We're going to be doing that. And then same concept applies here. If you have the same base for the log, in this case, both of these are going to be base 10s. You remember, if they don't write anything, it's base 10. We also kind of like base 10s because there's sometimes when we can use the calculator for all that base 10 stuff. So you may see a little bit of that in this section as well. But the key thing I want you to take here is, let's say you're dealing with both of these guys with the same base, then you can just take these and set them equal to each other, which is very nice when we are doing a lot of simplifying. Okay, and then the last piece, actually this right here is basically saying the same thing here. It's just that over here I made sure that you're noticing, all right, they have the same base, all right? They're saying the same thing, which is why I put them in the same color now that I'm thinking about it. So there we go. All right, I'm gonna zoom in on each of these examples because some of you guys are watching these on your cell phones and you need to see it. You gotta copy all these examples. So you might wanna pause it, copy this example. That's one example you're gonna need. Okay, then I'm gonna move on and you're gonna need to copy this example right here. Another one you're gonna need, take the time to do that. Then you're gonna need to take the time to copy this example right here. So I'm showing you this zoomed in on the screen right there. Again, take the time to copy all this down, zoomed in. All right, moving on. So let's do some of our own example problems. Okay, we're gonna go ahead and zoom in here on the first example problem. Here's our first thing we have to notice. You got a 3 here, you got a 27 here. We need to create a situation where we have the same base for both. We can do that because we can rewrite 27 to have a base 3. All right, so that's our first step, is doing that. So I'm going to go ahead and rewrite. We know that we have 3 to the power of 2x, but 27, that can be rewritten as 3 to the power of 3. This is the important step. Notice right here and here, now you have the same base number. And because you have the same base number, we then can use the rule that says, hey, same base number, that means our exponents are equal to one another. Real quick, that is this right here. Same base, exponents are now equal to one another. Okay, so that's why you have to take the time to write the notes. Then you can follow the example problems a little bit better. So let's scroll back down. So now we're actually just saying, 2x equals 3. Therefore, x equals 3 over 2. And that is how you solve the first problem right there. Create the same base number, exponents equal to one another, solve the new little equation that the exponents made, move on. All right, number 2. Now, I wrote a note off to the side right here, zoom out a little bit. So you're going to notice we can't do this with number 2, all right? They can't be written as a base 2 to the power of something. So in other words, what I'm saying here is you have a base 2, you have a base 15. You can't rewrite 15 as base 2 to the power of something. It doesn't work out. So we're going to have to use a different property here. We're going to have to take the log of both sides, and then we can use the power property of logs. Okay, so this, I think we can zoom in a little bit now. This can be rewritten as having both of them with a log base 10. All right, so let's rewrite this. We're going to say log. Remember, if I don't write a base, it's always a base 10. And now this is going to be 2 to the 3x equals log 15. Now, because they technically are using the same log base, which will go up, and just real quick, make sure that you see that right here. We're talking about this right here, and then this right here, because they are both now log base 10 with a whole number or with an expression, log base 10 again with a different expression. These expressions are now equal to one another. So this can now be rewritten because we did that. Before we do that, actually, we're going to use the power property. The power property is where we take this and bring it to the front. So 3x log 2 now minus log 15. You'll notice I took the log 15 and brought it over. When I brought it over, that's what created this minus. And then because I did that, we are able to use the quotient property that we used yesterday, or at least in the last section. Whether that was yesterday when you're watching this video, but it was in section 4. Okay, so now we're going to have 3x equals log 15 divided by log 2. All right, and this right here, you have to solve using your calculator. They're both log base 10s, so the calculator will solve this part right here for you. So you need to simplify that using the calculator. So you're going to get 3x equals, you simplify that down to 3.907, and then we can solve for x from here and get 1.302 right there. Okay, now I'm going to take a quick pause. We have plenty more example problems to do, but if you're struggling already, then we need to make sure we are a little bit more confident with the previous section, section 4, because we're going to be using a lot of those properties like the product property, the power property, the quotient property, all of those different things that we did. We're going to frequently bring those back. Okay, so you can gain more confidence, follow my example problems here, and repetition is key, guys. Repetition is so important. All right, those of you guys that are playing sports, repetition is everything. All right, all these guys in the NBA, they are doing so many free throws and three-pointers. That's their repetition. This is your repetition. All right, obviously you don't like this as much as your sport, but repetition is key. So let's move on. Here's more repetition. Let's take a look at our third example problem. Okay, something you should notice here is you are allowed to go kind of like backwards in a property. So what I mean by that is, do you remember what we just did right here? We took that 3x, we brought it to the front because that's the power property. We could do the opposite of that. We could take this 3 and bring it right back up here and put it there. So that 3 could go right here, we could go backwards in a property. It works with both directions there. Okay, and that's actually the first step that we're going to take. So we're going to leave all of this right here. And then we're going to bring that 3 right there. And we're going to go log x to the power of 3. And the reason why we're doing that is because we now want to use the product property. And that would mean we are looking at a log with the same base 10, same base 10. And because we are adding them, we could multiply these values right here. Okay, so we're now going to show that as 3 equals log 8x to the 3rd power. Okay, now comes a new little property or new little step for us here, where again, it's kind of like we're going backwards again with our base 10s. So instead of doing a log base 10, we're going to have a whole number or coefficient base 10. So here's what this looks like. If we were to put both of these parts here to a base 10, this is what it would look like. 10 now to the power of 3. By the way, this 3 is this 3. Now we're going to have 10 to the log 8x to the 3rd. Okay, now we can simplify this right here. 10 to the power of 3, that is 1,000. Okay, now here's a key thing. We're going to zoom in on just this part right here, because this is another one of the rules. Here's a 10, and this is a log with a base 10. So I'm going to write that in just so that we can see. This is one of the things that we used earlier in this chapter. If these two numbers are the same, you have this whole number here, you have that log base 10 here. If they are the same, you can then use the inverse property. The inverse property, if these are the same, allows these guys to essentially be crossed out and just use the 8x to the 3rd power. So that's what's going to drop down here, 8x to the 3rd power. Because we use the inverse property right here, the inverse property allows this to happen. Then let's just kind of go through our normal steps. Solving for x, dividing both sides by 8. These guys cross out. That leaves you with 125, which equals x to the 3rd power. And you actually are then going to essentially take the cubic root. Okay, so you ask yourself, what number to the 3rd power equals 125? And if you were to take the cubic root, that's the technical thing that we're doing here. If not, you could just kind of think of it in your head. There is a number to the 3rd power that works, and that's going to equal 5. Okay, all of this work right here to get down to simply x equals 5. Okay, so this is a big section for us. All right, let's move on. All right, 4th example problem here. All right, let's see. We again are going to go kind of like the opposite of the power property and take that 2 and put it right there. So that's our first step. So we have log x squared minus log 4 equals 0. And then we're actually going to do, we're going to move this to the opposite side, because you'll notice they have the same base 10. Log x squared now equals log 4. And there was the, I'm going to go back up in our notes because we are going to use this guy right here. Same base, same base. We can now say these two values are equal to each other. That's what we're looking at here. Okay, they're both log base 10s, meaning if they're log base 10s, we can now simply say x squared equals 4. And that's simple enough to say that x equals 2. Okay, a lot less steps in that one, but it's all about finding the properties that work. How do we manipulate the problem that's given with properties we know? And then that helps us simplify it down. Okay, let's do example problem number 5 right here. Okay, all right, this is going to be another one where we have to create the same base. Notice here's our base, it's a 2. There's our base, it's a 4. I can make the 4 become a 2. This one works, all right? So 2 to the power of x equals, now we're going to put this one in parentheses, 2 squared, because now we're looking at the same base. There's our base 2, there's our base 2. The x minus 1, that gets tagged on to the outside of the parentheses there, okay? And what we're then going to do, maybe this will make a little bit more sense. I'm not sure if it will, but think of this as distribute the 2 in here. So if you want, you could even write this in parentheses. And I'm going to rewrite this. This might make a little bit more sense to you. If we were to say 2 to the power of x equals, I'm going to put this one in parentheses, and then outside of it, 2 parentheses x minus 1. These are saying the same thing. It just might be a little bit easier if you're looking at this side right here, because now we're going to distribute the 2 into those parentheses. Okay, so it's now going to look like 2 to the power of x equals 2 to the power of 2x. All right. Sorry, the 2x minus 1. There we go. And let's change up our color here. All right, we're going to move to another property. Here's the property. Same bases. There we go. We have the same bases. So now we can say that these guys are going to be equal to each other. X equals 2x minus 1. Okay, and then we can move the x over, and that's going to leave us with a 0. 2x minus x minus 1. And now we can simplify it a little bit more. 0 equals x minus 1. And kind of one last step here. Take that, move it over here, and you're just going to get x equals 1. All right, let's zoom out so you can see all. That's the work there just to get x equals 1. All right, I believe we're looking at one more. Yes, one more example problem. Okay, so we are going to use the power property to take that 2 and move it in front. That's step 1. So 2 log x equals 6. Then, because all you're dealing with is just 6 by itself, there's no other log there, we can actually get rid of the 2 if we divide both sides by 2. Because now, think of this 2 right here as like a coefficient 2. All right? The log x has to go together. This 2 is just kind of in front of it, like a coefficient. So we can cross out those 2's right there, leaving us with just the log x now equal to 3. Okay? And now that base 10 is going to come back. We're going to have to use a base 10 for both. All right? So let's rewrite this as 10 log x equals 10 to the power of 3. Okay. And then we can simplify it a little bit further because the, let's see, the property, the inverse property. That's right. The inverse property, we have a 10 here. We have a 10 here. That's going to allow this and this to cross out, leaving just the x. Okay, remember that inverse property comes in real handy when you're trying to cross out logs. So there's a base 10, there's a base 10. So that's going to allow these two guys to cross out, leaving us with just x equals, and then 10 to the third power simplifies to 1,000. X equals 1,000. Long video, sorry guys, but there's a lot to be covered in this section, so I wanted to make sure we did as many example problems as we could. That's what I got for you. Ask me questions if you got them. I'll see you in the next video.